In this bite-sized video, we will explore the concept of trusts in the context of clinical trials that use patients' health systems data. We will look at the concept of trust in research, the importance of building and maintaining trust in trials using personal healthcare data, why trust might differ among individuals, and finally, the impact on trials using healthcare data if public trust breaks down.
Hello, my name is Ankit and I'm a clinical associate at Hardian Health. I'm a doctor by training with a special interest in the deployment of safe and effective clinical AI. At Hardian Health, we help researchers, industry and institutions build effective health tech from conceptualization and regulation all the way to economic valuation. In this session, I'll cover the key steps in the clinical evaluation of health-related software, particularly if it falls within the remit of being a regulated medical device.
Hi, my name is Lars Murdoch. I'm a health data scientist for the British Heart Foundation Data Science Centre. A large part of my role and the role of my team is building data pipelines for health data research. To do this, we often need to reuse code from previous projects or pipelines, or from each other. It's also important that researchers understand the steps in our code and that future researchers can follow a similar approach from our code for their own work. After watching this content on reusability, we hope you will understand reusability and its importance, recognize good reusability practices you can adopt, and be well placed to encourage good practices in others.
My name is Marcos Barreto and I'm Assistant Professor of Data Science at the London School of Economics and Political Science, and also a research on health data science. In this course, I'm going to introduce you to big data and distributed computing concepts and tools and show how we can use these tools to perform research involving data stored in electronic health records or captured in real time. In this first video, we will look at key properties of big data and how they relate to health settings. We will discuss big data analytics and how we can use different types of data and a combination of tools to acquire, integrate, process and understand this data. Finally, we will briefly introduce some big data and distributed computing tools that we are going to use later in this course.
In this video, we will discuss the roles of data engineers, data scientists and statisticians and when their expertise is best utilised. Data can be atypical in a number of ways, and finding someone who's worked with that type of data before can save you a lot of time and research. This could be spatial or geographic data, time series data, or data with so many dimensions it's not clear how to extract patterns or sequences of events, or identifying subpopulations based on the level of similarity. Both statisticians and data scientists will be able to point you in the right direction in these sort of situations, but when unusual data types arise, a fellow analyst in your department or departmental head can often provide great guidance. Getting to know your team, what projects they've worked on in the past, and if they've got any special interest within data is typically an easy step. That means you know.
Okay, let's first have a look at some code to get an idea of how differently styled code may look. Let's imagine we're writing a very simple function to list out all items in a shopping cart and compute their total cost. Here we can see how such a function may look in the R programming language. First we create a function, then we create a collection of shopping cart items, and in the end, we fill that function with a shopping cart. Can you spot any issues in the code on the left? You might already notice that given the way the code is written, it's not that easy to read despite the function being quite simple. To check a piece of code for common formatting issues, we can use what's called a linter. A linter is a piece of software with an internal set of rules that reads through your code and highlights any violation of these rules. The special thing about linters is that they can detect issues in your code without needing to run it. If we run the linter of our code here, we get the following results. Oh, quite a few different messages for so little code. We won't investigate all these messages in detail, but do note that each of them comes with a reference to the line it refers to and a detailed description of the issue.
Every house, flat, and business premises has its own individual, unique property reference number. This picture shows the UPRN for a well-known London address, number 10 Downing Street. UPRNs also identify locations we don't typically associate with an address. Each individual lamppost, bus shelter, and statue has its own UPRN. Have a look at this satellite view above Westminster Abbey. In addition to the church itself, UPRNs are assigned to statues and outbuildings. Local authorities need accurate locational data to ensure they provide the right services to the right location, and sometimes a street name isn't clear enough. In London alone, there are 113 streets named High Street or High Road. It could be costly, inconvenient, and even dangerous if a local authority were to pick up the wrong bins, turn off the wrong water, dig up the wrong street for roadworks, or grit the wrong street during a storm. It is important enough that local authorities provide services accurately that the government mandates UPRNs be used for all local authority operations.
Hi, my name is Joe Heffer. I'm a data engineer supporting researchers at the University of Sheffield. I help their teams to use data in an open, modern way. Our team collaborates with research projects to build data systems for a wide variety of applications. In this series, we'll introduce you to the fascinating world of data standards in health research. In today's digital age, data is everywhere. It forms the lifeblood of many industries and research areas. The ability to effectively manage data is becoming increasingly important. Without proper management, data can be messy, inconsistent, and unreliable. That's where data standardization comes in. Data standardization is the process of establishing a set of rules and guidelines for how data are collected, stored, and shared. This ensures consistency across different systems and uses. It's an essential aspect of data management. Without it, organizations struggle to make sense of their data, leading to errors, inefficiencies, and missed opportunities. In this course, we'll dive deep into the world of data standards, exploring its importance in health research and best practices.
In most cases, researchers have done comparison studies retrospectively. So at some point after the trial has concluded, we could apply for healthcare systems data and compare that with the data that was collected during the trial. In some cases, we might be able to do a prospective comparison study. So that would involve collecting both types of data in parallel while the trial is running. So why might trialists want to conduct a data utility comparison study? Now, unlike data that's collected directly from a trial, healthcare systems data is typically gathered for non-research reasons. Now, that means that we can't automatically assume that this type of data is going to be fit for use in measuring clinical trial outcomes. To measure utility then, researchers will often want to see how well a routine dataset would have identified outcomes that were directly measured in a trial. So researchers often create a 2x2 table to check whether a trial outcome was present in the healthcare systems data, the trial data, both datasets, or neither. And this kind of table allows us to assess agreement statistics like sensitivity, specificity, and false positive rates. And these can give a sense of whether healthcare systems data could have been reliably used alongside or instead of trial data. Now, if researchers find a high degree of agreement between the two different data types, they may be more confident in using that kind of healthcare systems data to measure outcomes in future trials. And generally, that can be a more efficient and less resource-intensive approach for researchers, participants, and for healthcare staff.